Hello everyone and welcome to today's online class for class 11. Today we are going to do a little bit of short class on isomerism. Now the definition of isomerism can be written as the phenomena of existence of two or more compounds which have similar molecular formula but different physical and chemical properties. The phenomenon of the existence of two or more than two compounds having same molecular formula but different physical and or chemical properties. For example, CH3CH2OH. This is an alcohol with hydroxyl group at the terminal carbon. CH3CH OH is also an example of alcohol comprising 3 carbon, but the hydroxyl group in the second example is situated on the middle carbon. So both of them have the molecular formula C3H8O, but both of the alcohols are not of the same compounds, having different kind of physical and chemical properties, but both of them have same molecular formula. So both of these compounds are isomers of each other, and this phenomena is known as isomerism. Now isomerism can be of various types. Structural isomerism and stereoisomerism. Structural isomerism, by definition, you can say that same molecular formula but different structure. Stereoisomerism a little bit different. Same molecular formula and structure but different orientation of bonds with respect to one another. Stereoisomerisms have following types. The first one is chain isomerism, position isomerism, functional group isomerism, metamerism, ring chain isomerism. Tautomerism. Stereoisomerism also have fewer categories. The first one is optical isomerism. Second one is geometrical isomerism. Last one is conformational isomerism. In structural isomerism, the first one was chain isomerism. Now, chain isomerisms, the example that we can study is this one. This is a very common example of chain isomerism, that is CH3, CH2, CH2, CH3. This is nothing but N-butane, normal butane. If we create a branching over this butane, the entire compound will look like this. This is nothing but isobutane. These are the two isomers of butane. Both of them have molecular formula C4H10, but both of these compounds are different from one another. The next example, the next category is the positional isomerism. Position isomerism. The most common example of this one is the example for the definition of isomerism that we had done, that is CH3 CH2 CH2 OH. This is N-propyl alcohol. And the isomer of N-propyl alcohol is this one, in which the hydroxyl group has shifted to the middle carbon, creating this alcoholic compound known as isopropyl alcohol. Only by changing the position of functional group in a compound, we create a different kind of compound, both of which have same molecular formula of C3H8O, but a complete different compounds. The third category was functional group isomerism. The most common example is CH3O CH3. This is dimethyl ether. Molecular formula is C2H6O. CH3 CH2 OH is nothing but ethyl alcohol or ethanol. Molecular formula is C2H6O. So dimethyl ether and ethanol both have molecular formula C2H6O, but one is ether compound, another one is alcoholic compound. So these two are, by only changing the functional group as a whole, are creating two different compounds but having similar molecular formula. So dimethyl ether and ethanol are isomers of each other, specifically functional group isomers of each other. The next one we are going to do is metamerism. The definition of metamerism is when two or more than two compounds have same molecular formula but different numbers of carbon atoms different hydrocarbon chain hydrocarbon group on either side on either side of the functional group such as etc are called metamass of each other. And the phenomena is known as metamerism. For example, this is an ether compound. This is also an ether compound. This is also an ether compound. All these ether compounds have the molecular formula C4H10O, but all of them are different. All of them comprising ethyl linkage, and the hydrocarbon groups on the either side of the ethyl linkage are different in each of the ether, thus is creating a type of isomerism known as metamerism, and all these compounds are known as metamers of each other. This type of metamerism can also be seen is this kind of compounds also. The next category is ring chain isomerism. There are two examples that we are going to study to understand ring chain isomerism. One of them is this one, CH3 CH double bond CH2. This is nothing but propene. This is a ring compound of cyclopropane. Both of them have molecular formula C3H3. C3H3. Both of them are isomers of each other having similar molecular formula of C3H3, but one have a chain structure, another one has cyclostructure. That's why the name suggesting ring chain isomerism. The second example of this we are going to study is this one, CH3C triple bond CH. This is nothing but propyne. and this is cyclopropene. Molecular formula of both of them C3H4, but having different structure, one having a chain structure, another one having a cyclostructure. The last in the structural isomerism that we are going to study is the tautomerism. Now there are some condition for this kind of isomerism or tautomerism. That is, the first condition is that there must be a presence of alpha hydrogen. And the functional group that participate in this kind of tautomerism are these. Ketoenol tautomerism comprises this functional group. Supposedly, this is the structure of acetaldehyde. This is the aldehyde functional group, and this carbon is the alpha carbon, and these hydrogens, these three hydrogen are alpha hydrogen. So there is a presence of alpha hydrogen in acetaldehyde. Therefore, this acetaldehyde do undergo tautomerism. How? Now, a dynamic equilibrium exists between this form in the left, which is known as keto form, and this form on the right, which is known as enol form. Now, enol forms are unstable as the same carbon contains a double bond and hydroxyl group, which makes the hydroxyl group unstable, prone to rearrangement to the keto form. That's why in the solution of ketone or aldehyde where an alpha hydrogen is present, ketoenol tautomerism is observed, but the keto form can be found to be in higher amount in that solution compared to the enol form due to the higher stability of the keto form compared to the enol form. Now this entire thing is known as ketoenol tautomerism, but there are certain compounds which do actually give a certain amount of higher stability to the enol form, like this compound. This is dione. This is an alpha hydrogen, and thus it is undergoing tautomerism. And when it is undergoing tautomerism, this is the structure that is being formed in the enol that is formed after tautomerism as an enolic form. A hydrogen bond is observed, which results in this kind of 6-member ring. We know that 6-member ring are extremely stable. That's why this enolic form is stable compared to the keto form. Now, in stereoisomerism, the main one that we are going to study is the cis-trans isomerism in the geometrical isomerism. The example that we are going to study is this one. But 2-ene. Now there are two isomers of but 2-ene. Double bond cannot be rotated on the molecular axis. That's why the orientation of groups with respect to one another are fixed. If the similar atoms are placed on the similar side, then it is cis-butene, cis-butene. And if the similar groups are situated on the opposite side, then the compound is the trans isomer. As the double bond cannot be rotated on the molecular axis, that's why cis trans isomer cannot be converted into the trans isomer. As a result, the two entities are having quite a bit different physical and chemical properties. Like in cis-butene, the cis-butene are a bit unstable compared to the trans-butene due to the steric hindrance that present between the bulky methyl group situated on the same side. Whereas in the trans-butene, as the bulky methyl groups are situated on the opposite sides of each other, that's why the steric hindrance cannot be observed in as such amount, resulting in comparatively stable, comparatively more stable structure than that of the cis-butene. These are few are the characteristics and types of isomers that we had covered today in our class. Go through all of them and try to study as much as amount of examples of each of the isomers. These are the basic definition and some basic well known examples of isomerism.